Today we will study the concept of tangent vectors. The term tangent vector includes two words, one is tangent, another one is vector. Tangent means it is a line segment which touches a curve or any figure at one point. Vector means it is a directed line segment. As we are studying all the concepts in Euclidean 3 space E3, so here we will study the concept of tangent vectors in 3-dimensional space E3. So we will note on some points. A vector in E3 is an oriented or directed line segment or an arrow. Coming to definition, a tangent vector, which is denoted by VP to E3 3-dimensional space, consists of 2 points of E3. One is its vector part V, another one is point of application P. Here we describe an arrow in E3 by giving its starting point P, which is called as point of application, and the change or the vector part V, which is necessary to reach its endpoint P plus V. So geometrically we can say that VP as the arrow from the point P to the point P plus V, that is the direction of the vector is from the point P to point P plus V. So if I draw this tangent for a curve, that can be, if this is a curve and it is a point P, this is a point of application. So the tangent vector is from P to P plus V. So that is denoted by VP. This is about tangent vectors to any curve in E3. This is a curve in E3. P is a point in E3 which is called as point of application, and VP is called a tangent vector. Here V is called vector part, which is any point in E3. So to know it well, consider an example. If suppose P is a point in E3 which is given by 1, 1, 3, and V is equal to 2, 3, 2, then the tangent vector VP is a directed line segment or an arrow which runs from P to VP plus V, that is from the point 1, 1, 3 to the point 3, 4, 5. So this is the example of a tangent vector. Now let's see some concepts on tangent vectors. First one is equality of tangent vectors. Equality of tangent vectors. Suppose we are having two tangent vectors VP and WP. Here P is a point of application. V and W are vector parts. These two are said to be equal if and only if they have same vector part. Vector part P and W, that is, so V is equal to W. Already we have taken the point of application as P only, therefore two tangent vectors are said to be equal if and only if they have same point of application and same vector parts or equal vector parts. So next we can see the parallelity of tangent vectors, means parallel tangent vectors. Here we consider two tangent vectors VP and VQ. So they are said to be parallel only when they have different points of applications but same vector part. Here for VP and VQ to be parallel, so both are having same vector part, Q is not equal to P. So to write it in a well manner, two tangent vectors are said to be parallel if and only if they both have equal vector parts but different points of application. So here it should be noticed that P is not equal to Q. It should be remembered.